Hello guys, welcome to this series which is on machine learning fundamentals. We were in fact discussing some of the significant machine learning algorithms, and in that category we had in fact discussed in this particular episode KNN and the related concepts, in fact the distance matrix, and then we went on discussing KNN completely. Today we are taking one more very important machine learning algorithm, which is naive Bayes, and we'll be going to the basics of it, giving one sample program, in fact, which will be on similar student prediction, so that we can have better understanding of the things at the basic level, and then we can go to the advanced implementation. So, without any further delay, let me just uh, present this naive Bayes classifier. Naive Bayes is a supervised machine learning algorithm. It is mainly used for classification. It's a supervised machine learning algorithm mainly used for classification. It is based on Bayes' theorem, which in fact we are going to open up to some extent. And why this is called as naive? Because it assumes that all the input features that are there, they are independent of each other. So for example, in case of a student, if for example study hours are there, attendance is there, assignment marks is there, normally we have seen that algorithms do have a relation. They are establishing a relationship between these different features, and then outputting a result for a particular student. That means if the student's study hours are less and the attendance is also less, it's probably a fail case, or the classification will be as failure. In the same manner, if you are having assignment marks as higher and study hours as higher and attendance as higher, we'll be predicting, or the model will be predicting it as a pass case, or classification will be pass. But in naive Bayes, it is different. It is treating all of these features independently. So there will be an independent effect on the student, students pass or fails. It will be independently affecting whether a student is pass or fail in reality. So these features, may be related, but naive Bayes still works surprisingly well in some of the classification areas, real world areas, where it is considering these as independent features, and it is still providing a very good percentage of accuracy in some of the real world problems, and predicting that with good accuracy. So this is what naive Bayes is at its base. So fundamentals. Now if we go to this Bayes theorem, you can just see this is the relationship which is there. Probability of class C given data X. So that is what it is saying here. So and probability of data X given class C, and prior probability of class, and probability of data separately. So it is taking all of these into consideration. For classification, naive Bayes chooses the class with the highest weight. So that is calculated with this particular, expression, which is mathematical expression, which is given there. So it will be giving the max. So it will be giving the highest probability. It will be choosing for classification. I think this particular thing which we are having here, it will be much more clear with an example. So I'm going to show you the example. So what it actually means, what does this, this all which is here, the mathematical expression which is here, what does this all mean? Although you should be knowing this, expression, remembering this, what it is. But if we open it up, what does it mean? So calculate the probability of each class and choose the class with the highest probability. So what this theorem is doing, actually, Bayes' theorem is doing, it is calculating the probability of all the classes, and then it is putting the highest probability. In fact, with the highest probability, any class with the highest probability, it is choosing that, and giving that as an output. What, for example, if we are taking a sample example, And in this one, we have taken one very easy and simple one, which is, suppose we want to classify whether an email is a spam or not spam. So first of all, what naive Bayes will be doing, if email contains words, so we are calculating the words, this will be classifying. So in this one, in fact, naive Bayes is having multiple types, which we are going to discuss. So one of them is, in fact, used for calculation of, for counting of words. Free winner offer are the words. Naive Bayes calculates if the words spam words are more. So p spam words and p not spam words. If p spam words are greater than p not spam words, then the email is spam. So it's a very simple thing. We are having spam words, we are having non spam words. It is calculating them, and the probability it is checking, and then it is checking that the probability of this mail being spam will be more, because it will be checking all the occurrences, and in occurrences it will be calculating spam words which are there. So if the spam words are more than non-spam words, it will be putting the probability of this mail being spam as, more than not being not as spam. So it will be classifying the mail as spam. So this is very simple, exact expression which is given here. This expression which is on your screens now, exactly it is doing this in, by calculating this these spam and so probability of these. So probability of class C, given the data x, and definitely probability of data x given the class C, and then the probability of the class itself, prior probability of class, and the probability of the data. So it is applying that here, and then you can just see naive Bayes is different from KNN. Definitely KNN is a different machine learning algorithm. Naive Bayes is different. There are certain aspects in which KNN and naive Bayes are compared here. Learning type, is KNN is considered to be lazy learner. Probabilistic learner is the naive Bayes. It is using nearest data point. It uses the probability. So so probability will be there, not the nearest data point. It is based on, prediction is based on distance. It is based on Bayes theorem, which we have seen. Uh, Training speed is very fast for both of them, and the prediction speed is slower for KNN. It is faster for naive Bayes. And then feature scaling important, usually not critical. So that scaling of features is very important as far as KNN is concerned, but it's not that critical for naive Bayes. Works well with text data. I think text data, we can just say that a specialized kind of algorithm, machine learning algorithm, will be naive Bayes. So it is moderately good KNN as far as the text data is concerned, but if you just see naive Bayes, it is working excellently in such kind of data. Interpretability, easily visually, so easy visually, so we can visually easily view, as we have seen in the KNN, for example, different kinds of distance matrix, and with that we are able to visually view it very easily. Statistically, we can just see naive Bayes, not visual, but statistical analysis kind of a thing will be very well with naive Bayes. So these are the areas. Definitely, we are having KNN. Is there are key differences? KNN is asking for which training examples are closest to new examples that we have seen, the neighbors which are there. And on the contrary, if you just see naive Bayes, which class has the highest probability for the new example. So for this new example, so which class is having the highest probability that it will be fitting this new example, so it will be doing the classification in that category, in that way. So these are types of naive Bayes. Gaussian naive Bayes is there, multinomial naive Bayes is there, and then Bernoulli's or Bernoulli naive Bayes is there. So Gaussian is used for continuous numerical data. We are having multinomial naive Bayes, which is used for text classification, word counts, as I was saying, and binary features. Yes, no word presence is using, in fact, Bernoulli naive Bayes. There are, in fact, advantages and disadvantages. This is some theoretical portion. I think you can just go through this very easily. Simple and fast, works well with small data sets, excellent for text classifications, performs well even with many features. easy to explain and implement. Cons are definitely assumes features are independent, may perform poorly when features are strongly related. We might be having a data in which features are very strongly related. We can take this example of a student's performance itself. There are certain features in that which I believe they are very strongly related with each other, and that can have a significant impact on the result of the student. So that might not be a very good example for or a good use case for naive, but there are others which are for example calculation of words or spam or not spam based on the signature or the words which are there. Less flexible than advanced models. Probability estimates may not always be accurate. That is true. And if you just see this in implementation, so I am just showing you this implementation of this Base. In fact, I can run this particular algorithm, particular program once again. It is just starting with the certain libraries, importing those, and then the data is there. In which we are just taking this example of students' performance, student data, student study hours, attendance, assignment marks, and then definitely the results. So we'll be putting it X and Y as we are doing. And then we are splitting it train and test. So that is here 0.25%. The 25% of the data is taken as a test data. And then random state 45 that you are aware about. We are putting a Gaussian, using Gaussian, variation of this naive Bayes, and then we are fitting the model. And in fact, because Gaussian will be appropriate here, because we are having, if you just see again, the Gaussian is there in the numerical problems. It will be fit. And then we are having other categories. One is for definitely for the word count, which we have seen earlier. Now we are putting this, so training the model, predicting the test data, and then we are evaluation is done. Then accuracy scores and confusion matrix, classification report, all of these. And then we are predicting a new student with the marks of study hours of 6.5, 75%, attendance and assignment marks of 70. So this is the new student which is predicted, and it is giving the prediction. So it will be a prediction as a pass or a fail. So we'll see how it goes. So let us just very simple code which is there. And we will just run. We'll say run without debugging, and then it will be giving us first of all, accuracy is 100% in this case. Confusion matrix, if you can just see, 1002. So it is perfectly predicting everything. So we are having accuracy of 100%. You can just see that. And then other parameters which are there, recall, F1 score, all of these. The new student is predicted as pass. So based on this, because the probability of this student with all of these things, the probability class which is there, so higher probability class will be, it will be either pass or fail, but based on the characteristics, the probability based on this Bayes theorem, it will be predicting here as pass. So if you just see this, again, we have seen that, Gaussian naive Bayes, which we are using here in this particular example, which we have used, that is, in fact, the one which is used for continuous numerical data. So that was, the example which we had given in Python. And multinomial naive Bayes, we might be giving, in future we'll be taking some examples in this, text classification, word counts. And Bernoulli naive Bayes, it is binary features, yes, no words. There might be certain areas in which we can use this particular classification as well. So I want to keep it short. In fact, short videos are less boring if you are getting a single concept. For example, this time around we have taken in this is episode 15, in continuation of episode 15 we are going. We have taken some of the major machine learning algorithms in this. So first one was KNN, naive Bayes, and we'll be going to one more in this particular series itself. And the related concepts that are there, we are taking them as we have to take a new, for example, new machine learning model. In this one, we have gone through Bayes theorem, and on the basis of what it is, working. At least, when we are talking about fundamentals of machine learning, you should be having background of a concept first of all, on the basis of which a model is working. The foundational concept, we can just call it. It may not be something very deep, but at least you should be knowing where from these calculations are happening, and that is what we are trying for these fundamentals of machine learning. That any related concepts which are there, that we had taken, for example, in decision trees as well, talking about, for example, Gini impurity, and information gain, and other concepts which were there. So until unless these things are there, you will not be able to understand the algorithm. So it is very important, whenever an algorithm is taken, first of all we have to just go through the basic concepts which are there. May not be very deep as far as the fundamentals are concerned. Then when you are applying it at an advanced level for that particular algorithm, whatever calculations, mathematical expressions which are there, you can deep dive into them if you are in fact using that particular model in an advanced stage. But in the fundamentals as well, you should be knowing the basics of it. So we are trying to give that, those basics for all of these algorithms. Thank you so much once again for joining, and please provide us your valuable feedback. That will be very critical for us for the upliftment of this, and we'll be providing you, in fact, then better learning material, and in fact the sessions which are having better impact, and the viewers can have a better understanding. So feedback is very important. Do subscribe to this channel in case you think that this is helping you. So see you on the other side with one more algorithm in this category, with the related concepts as well, and the Python implementation. Thank you so much once again for joining.